Hello, this is part 2 of module 2, and in the previous part we have seen the content of the Excel data model, what's in it. It's made of tables and relationships. If you haven't watched it, I would recommend going back and watching it, because everything that we're going to do in this part is based on what we just started to do in the previous video. So we finished by having a pivot table populated from the data model. We've seen that the data, the field list here on the right side contained multiple tables, and I was able to drag things from each one of the tables and to create my first pivot. One more thing I want to show you here before we dive into the data model using the Power Pivot add-in is I dragged, and by default, because I dragged something which is a numeric, the revenue, it created a value of sum of revenue, which is the same behavior as Excel will do with native pivot table from grid data. But there's, for example, there are things which are possible here which are not possible with a regular native pivot table. So for example, if I drag the customer key to the values area, by default, it will do something that is not really very useful, which is the sum of customer key. But I can go and change it to use another aggregation. And if you see the bottom one, the very last one of the aggregations is very, very important. This is the distinct count. Distinct count, so now what I see is for each combination of country and category of products, I see the number of customers that actually have purchased this combination, the bike in a country, unique customers. In the same way, I can drag now a product and show you how many different products were bought in a combination and so on. And this is something that is impossible to really do with a regular pivot. And in general, in many other tools, it's very, very difficult to do. And you can see that with the same speed, and I can immediately calculate this result for any combination of slicers and so on. So after we saw this tool, let's me go back to the window that we saw in the previous model, the window into the data model, the manage. And in here, continue to do a few more things. So first of all, if you noticed, the revenue that I used was not really formatted nicely. I can, for each one of the columns, I can apply a format. I can go, for example, and say that this is currency. So from now on, every time I use this column, it will be formatted appropriately as a currency. But what I want to do now is I want to create something. In the previous video, we created 2 calculated columns. Now, the syntax for these columns, maybe you wonder, what is this syntax? It looks very much like Excel. Is it really just an Excel formula? Actually, it's not. It's this expression, which is a very simple one, but still is written in a language called DAX, D-A-X. And DAX was created together with this, with the data model. And it starts by being really very simple, but it goes way, way beyond that and into some very sophisticated options for calculations. Now, DAX can be used in Excel in the data model in 2 different positions. One is for calculated columns, and one is for measures. Measures are there are multiple ways to do them. One way is to use this area here below the rows in order to create the measures. So let me start creating some simple measures and show you, for example, I can, if I want to create a measure for the total revenue, I will call it total rev, and the syntax is name, colon, equals, and now I start to create an expression sum of revenue, and I complete it with tab, close parentheses, and I have the results here, and I can also go and format it, let's say, to be a currency. This is my first example of creating a what is called an explicit measure. Actually, I created already measures behind the scenes. If we go for a moment back to the pivot, when I dragged anything to the values area, it actually was creating for me a measure behind the scenes. This is called an implicit measure. But what I just did was to replace this implicit functionality by explicitly creating measures. So this one is not more sophisticated than the other that I was creating by dragging, but there are reasons even for this kind of simple example to create explicit measures, and it's a good practice to use them exclusively. Now, I can also create another one, for example, for the tot cost. And I would say tot cost, sum of, and this is sum of the cost column in, and again, format it as currency. Now I will create a third measure, which is a little bit more sophisticated. And this one will be calculating the margin percent. So once I have the revenue and the cost, I can calculate the margin percent. So margin percent, colons equal, and here I will say, open parentheses, revenue minus cost divided by cost. So I'm not referring to columns in the table, but instead I'm referring to other calculated measures that I already created. I will format this as a percent. And going back to the my pivot, I will take out the two. Well, this is, I still haven't replaced it, so I will, for now, I can leave it or I can take it out. But I want just to show you that now, when I go back to the list of columns in this table, the main table, I see the tot rev. I can click on it, the tot cost, and the margin, which is a percent. And I can still, of course, slice it by year and calculate it every time. Now let's stop here for a moment and actually understand what has happened when I created this measure. I created this measure once in here, and I just said that this is the sum of, so this is like the margin, but this is it's just the sum of the column revenue. Although I defined it once, every time I see its use, it's giving me a different number. And the reason it's giving me a different number is that it's being calculated fresh every time with a different context. And the context, like in this cell here, is Australia bikes in 2006. So this is the sum of revenue, and this is the sum of cost, and this is the margin for this combination of Australia bikes and the year 2006. If I go here, this will be another calculation. Again, every time it's another calculation. If I go to the grand total, again, it's a calculation of this measure. It's not a sum of this column here. It's actually a new, fresh calculation with a new context. So this is a very, very important principle for the DAX language that we're going to see, and I will repeat it a few times for you to grasp the importance of that every measure is calculated within a context. And the context by default comes from, if it's used in a pivot, there's something on columns, something on rows, some slicers, a filter maybe for the pivot, and so on. So all this gives a context in which the calculation is calculated. So this is for measures. Now, what about, let's switch back for a moment to understand more about the calculated columns. Do they also have the same filter contents? Well, actually they don't. They have a different context. When I calculate this calculated column, it doesn't see the pivot that will be eventually be used or built from that. It actually sees the row that it lives in, and it can use any other column in this row of data. So in this case, it's used the order quantity and the list price. It could also use columns in other tables, like an extended row. And why is that? It is because of the relationships. The relationships make other columns to be kind of related to this one. So for example, for each row here, I have the product key. So every property of the product I can use here. Or I have the customer key. So because of the relationship with customers, I can use data from the customers in here if I need to. Let me give you one example to create such a calculated column that is using the context, which is called the row context, to let's go and, for example, into the product table. And in the product table, I have this data, and I want, let's say that you saw that I have product category table and product subcategory table. But those two tables are actually used just from one column each. The DIM product category has the category name, and the subcategory had the subcategory name. I may have a goal to reduce the number of tables that my user sees when it creates a pivot table. In order to do that, I can actually create a column here in the products table that will have the category name, for example. So in order to do that, I create a new column, and I use a DAX function called related. Related means I'm going to use a column from another table, but that is related to this one. And immediately it gives me the list of options of things which are related to where I am. And the first one is what I want. I want the category name. So give me the category name for this product. So it goes and it brings the necessary data from the other. Now it seems as if it didn't bring anything, but it actually did, because there are some products in the beginning that do not have the right connection to subcategories and so on. So it seems empty, but it's not. And I can call it category. So now I have a category column in the product table, and this will also enable me, so I have here, see the list of bikes, clothing, components, and some products which are actually have a blank for the name of the category. So once I have this, I can actually say that I don't need the product category. I can go here, right-click, and say, just hide it. I don't delete it, but I hide it. So when I go back to my pivot table, I will see that the product category table have disappeared. And if I open the DIM product table, I will see that it has now a new column that wasn't there that is called the category. And I can use this instead of the original one that came from the category table. So I reduced the number of tables, and I added a calculated column from a related table. So this ends the second part of this module. We've seen the data model, we've seen relationships, we've started to see calculated measures using DAX, and we saw the use of calculated columns. The measures are calculated within a filter context, while the calculated columns are calculated within a row context. We're going to use a lot more of the measures, not so much calculated columns, in subsequent modules. I hope to see you there.